Hello and welcome back to KHW2.6, the last key for the last homework of the second unit. What angles of rotational symmetry are there for a regular pentagon? Hey, this was on the last test. 72 degrees and also multiples of 72 degrees. 144 degrees. 216 degrees, 298 degrees, and then 360, which is not technically a rotational symmetry, but it would complete the set of 5. What angles of rotational symmetry are there for a regular hexagon? Also from the test, depending on which version you get. 120, 180, 240, 300. If a regular polygon has an angle of rotational symmetry of 40 degrees, how many sides does the polygon have? Well, now you take the 316 divided by the 40 degrees. 9 sides. A nonogon. On each given coordinate grid in problems 4 or 5 from the indicated transformation. Reflect P over line J. Yeah, you gotta measure this. It should be down here somewhere. I don't have a ruler. My rulers are upstairs and I'm in quarantine still. Till tomorrow. Something like that. Hopefully I don't need a ruler again. Surely I would never. Clockwise around point C. Okay, 90 degrees. So without patty paper, this is how I do this. I'm going to move this 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. Over here. Then rotate it 90 degrees clockwise, which would take me over here. Because I'm using the grid system, so if I'm over here in this quadrant, 90 degrees will be over to here, this quadrant. Same spot, different quadrant, because each quadrant is 90 degrees off. But now, we need to move the C back. 1, 2, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. Tricky. Isosceles. I don't have a ruler, but I do have. I do maybe have. So you have to put your compass set to everything except C to D length. Anything else will work. This will work. And as long as the other two sides are both that. Okay, I guess I gotta go find a ruler. Just kidding. Use this card. You get the idea. Isosceles. Regular hexagon. Man, we haven't done this one. Let's see if I can remember how to do it. Okay, I think it starts like a equilateral triangle because that's how you find the center. So you reach with that length into the middle and find the only spot that's the same distance from both these points, which is this spot. And then you make that circle. And now you can do it just like the first hexagon we ever built, which is to march around the circle, both directions. And how close are we? Oh, off by one. Why am I so far off? It has to do with just picking like the exact Weird. That should be way better. Maybe. Aha, that explains a little bit of it. My circle was slightly off. So let's try again. Using the new circle. There we go. See, this is what I'm talking about. There we go. There. Oh, now it's perfect. So I just pinned my circle in the slightly strong spot, and it messed up my whole hexagon. Stupid peeper. Okay. I need to upload this video, so I'm not even going to go back and fix that. It's a perfect hexagon. Construct a square with CD as one of its sides. Construct the circumscribed circle? We never did that. I hope you had a fun challenge with that. Extend. Reach out to make the perpendicular line. So, reaching out there. Now, reaching back in. Got to make the compass bigger. I just made the compass bigger right there. Here's my 90-degree corner. Now, I have to set to this side because squares have all the same sides the same. Reach out, get that corner, reach out from there. X marks the spot. Reach out from there, reach out from there. Now, how the heck... Oh, I know how I can do it. The diagonals of a square cross in the middle. So, whoosh. 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 I don't know why they wanted us to do this. Da-doi. I don't know if I was on the screen. Was I on the screen for that? I was mostly on the screen, right? Which of the geometric constructions is used the most? Circle. Oh. I don't think that's actually what they want. They want perpendicular bisector. When you watch the heptadecagon video, this construction is so common that he skipped it. He kept on saying, "I'm not even going to do it. I'm going to eyeball it. I have to do it. We have to do it so much." Which made his construction less accurate. However, he said even if he did do it, it still wouldn't be accurate because there's too many little mistakes, whether you eyeball it or not. Also, I'm doing this on not a surface. Sorry. Doing this on like a fabric bench. You know what? I'm glad we're doing this parallelogram again. I feel like this is the construction we've done the most. We did a lot of rhombuses, but then they also threw in a lot of parallelograms. Oh, I have to open it up to this size. Measure. This is the sloppiest homework. I'm so sorry, guys. Sequence of transformations used frequently to show that figures are the congruent. Oh, yeah. Translate point to point. Rotate till sides on side. Reflect if necessary. Y is on top. -6, because -5 minus 1 over 8. -3/4. Distance. (64 plus 36, 10). Next one. I'm just going to do this for the next page. Y is on top. 31 minus 11. -10 minus 20. 20 over -30. That's -2/3. Man, I wish I would have given myself more time, place for distance over here. -10 minus 20 squared plus 31 minus 11 squared. -30 squared is 900 plus 400. I think you can just leave it like this, square root of 1,300, or a decimal approximation if you have a calculator handy. Oh, that was the last problem. How anticlimactic. All right. Have fun. See you guys tomorrow, hopefully.